Today in class we learned two new exponent rules, and we're going to use those rules today, or now, to simplify expressions using those quotient rules. Okay? All right, the first thing we did was dividing powers with the same base. So I want you to see if you can write the rule by yourself. When we divide powers with the same base, what do? Write the whole rule, pause the video, or first pause the video, then write the whole rule, then see if you remember the first rule. You can look at this as an example. What do we do when we have that situation? Did you remember it? When dividing powers with the same base, you subtract the exponents. So a to the fifth divided by a to the third would be a to the 5 minus 3, which is a squared. Okay? Now, the second one, we had a quotient, or really a fraction. A fraction is a quotient, raised to a power. Pause the video, write that rule, and then see if you remembered it. We said when raising a fraction, which is a quotient, to a power, you raise the numerator and the denominator to the power. So 3 halves, or 3 over 2 to the 7th power, would be 3 to the 7th power over 2 to the 7th power. Those were the two rules we looked at and discovered in class today. Now, in class you did some practice with just basic problems, nothing fancy, you just used those basic rules. Let's look at some problems where some of these rules are used all together, okay? I'm going to do a couple with you, and then I'm going to let you try some on your own. Let's look at this first one, x squared over 4y raised to the 4y. So we want to give that out. This is a fraction to a power. So we're going to raise x squared to the second power, and we're going to do 4y to the second power. I raised the numerator to the power, I raised the denominator to the power. So now I have to use my other rules. What have I got right here? I've got a power to a power, so that's x squared squared, which is x to the 4th. And then I look at the bottom, and what's going on right here? I've got a product raised to a power, so I have to give that exponent out. I'm going to have 4 squared over y squared. I can finally clean it all up, and I get x to the 4th. 4 squared is 16, and y squared. So that's my final answer for that one. Now, look at the next one. I've got negative 5 over y, all raised to the 3rd. It's important here that you look at this negative. It's in parentheses, so this negative is part of the base, right? So I'm actually raising the negative to the 3rd power. What's a negative to the 3rd power going to be? It's going to be a negative times a negative times a negative, which is going to be negative. And then I'm going to have 5 to the 3rd over y to the 3rd. On these, they want you to go ahead and work out your numbers. So this is going to be negative 125 over y cubed. Okay? All right, I want you to pause the video, and I want you to try this one on your own. Then turn the video back on and see if you got it correct. For this one, I see I had a fraction, so I raised the numerator to the power and the denominator to the power. Then I had a product to a power, so I gave that exponent out to the 4 and the x squared. I gave this bottom exponent out to the 5 and the y cubed. I simplified, and I got 64x to the 6th over 125 y cubed. Okay? Make any corrections, make any notes of anything you don't understand. Now, here we see some a little more complicated. I've got a fraction to a power, and then just a normal old little fraction over here. Okay? So let's see. Since this is a fraction to a power, I'm going to give that 5 out to the numerator and the denominator. So I'm going to say a squared to the 5th power over b to the 5th power. And then this 1 over 2a squared for right now is just going to tag along. Okay? Then a squared to the 5th power. Got a power to a power, so I multiply. And I get a to the 10th over b to the 5th. And I've still got this 1 over 2a squared. Now, what's going on right here? This is dividing, right? So I'm subtracting the exponents. We could combine this if we wanted. Since we're multiplying fractions, we could say a to the 10th over what? 2a squared b to the 5th. Okay? Now I can see maybe a little more clearly that I'm dividing, so I'm going to subtract the exponents. I'm going to get a to the 8th on top and 2b to the 5th still in the denominator, because the a to the 10th over a squared, I subtract the exponent since I'm dividing, and I get that a to the 8th. Okay? All right, this other one's very similar to it. You try it, see how you do. This one's a little more complicated, got a little more going on. So look what happens here. I had a fraction raised to an exponent, so I raised the numerator to the exponent, the denominator to the exponent. Didn't do anything over here, not quite sure why those are in parentheses, we don't need them. Then I had a product to a power, so I did 2 cubed s cubed. Same thing on bottom, 3 cubed t cubed, and this is still just tagging along at this point. 2 cubed is 8, 3 cubed is 27, this is tagging along. Now, these are fractions, so I multiplied straight across. So I got 8 s cubed t to the 5th, I went straight across, 27 t cubed times 16. And I should probably have a multiplication symbol there. Now, the reason I left it that way is I look and I go, well, I have an 8 on top and a 16 on bottom. Those cancel, 1 and 2. Now, when I do my 27 times 2, I get 54 in the denominator. S cubed doesn't have anything else going on, so it stays in the numerator. And right here, t to the 5th over t cubed, I'm dividing. What do I do to the exponents? I subtract. So I got t squared, and I ended up with s cubed t squared over 54. There are lots of ways to get to the right answer. Make sure you're showing enough work, the amount of work that you need to get it correct. Mark anything you don't understand. We're going to do practice with this in class.